Programming Throwdown, Episode 78, Building and Testing Web Services with Postman. Take it away, Jason.
Hey everyone, so I'm here with Abhinav Asthana, and we're going to be talking all about web services. And before we jump into web services and REST and API and all these things, Abhinav, why don't you kind of introduce yourself, tell us sort of your background, and tell us a bit about Postman.
Sure, yeah. Thank you, Patrick and Jason, for having me on the podcast. Really great to be here. So let me start a little bit about myself. I have been a programmer most of my life until recently. Moved into something more on the management side, I'd say. So I started, programming kind of in sixth grade. Have been a self-taught programmer. Got an engineering degree, but that was kind of in electronics.
So what did you make in sixth grade? Like a video game or something?
So I started with, first I started with basic, the stuff that was taught in school. And then I kind of went to C++. And my dad was very interested in programming. So he used to learn stuff like Visual Basic and Visual Fox Pro. So I kind of picked that really up. And from there, I kind of went to Flash and ActionScript.
Okay.
And then ended up making a web app through some, sequence of things on PHP and MySQL. That's what I remember.
Cool.
Yeah. So, I've been working on code for a while, and through, this kind of experience of writing code, ended up doing a bunch of stuff, I'd say semi-professionally along the way. I had a bunch of friends in school and in college. We used to kind of, design and develop apps and websites for other people. We take up consulting projects, kind of get paid for it, which was pretty cool.
Well, that's pretty entrepreneurial, right? Like you're in college and you're doing these projects on the side and kind of already sort of starting a business and getting a brand and all of that.
I like coding a lot, and it's doubly awesome if you get paid for it.
Yeah.
Working with clients at that time was tricky because you have school to kind of go to, but I liked it a lot, and it taught me a lot in the process. And I kind of knew that whatever I'm going to do after college is going to be related to programming or designing something. I didn't know about products very well at that time. We just used to work on websites or kind of web applications then. But yeah, kind of after college, I found my first company with a bunch of folks that was called Teleport Me. And there I was basically building kind of what you might call a social street view sort of a thing. This is in 2010. We were kind of building an app that would help you kind of capture panoramas and share it with the rest of the world. And we built that on Android. So kind of got featured on the Android app platform. So it was pretty interesting. We raised a bunch of money and had a lot of fun, while working on it. But, kind of after that, I started Postman as a company. So Postman as a project had kind of existed for a while. As I was coding and working on stuff, I used to work with APIs a lot. And Postman kind of came off as a side project of mine. And now, of course, it's like a company with people, and we have products and things like that. But yeah,
cool.
Hopefully,
so we'll talk more in detail about Postman. But just can you give us kind of a one-liner of what is the sort of core product?
Yeah, so Postman is an API dev environment which helps you design, test, debug, document, and monitor APIs.
Cool. That makes sense. So is it specific to web, or is it, does it work with shared libraries, or it's probably mostly web, right?
Yeah. So the APIs in this context that we help developers work with are HTTP APIs.
Okay.
So if you have stuff kind of going over the network and it's on HTTP, that's the stuff that we help you, build and test.
Got it. That makes sense. Yeah. So, a lot of people, I mean, even my grandmother, when she hears HTTP, she kind of knows, oh, it's the internet and web pages. And so most people have like a basic concept of, I go to HTTP, google.com, and I get the search box, right? So, what is sort of the difference between, I type in google.com and, the kind of web services that you're talking about, right? I mean, they have HTTP in common, but they're kind of very different sort of user experiences, right?
Yeah, I'd say from a user experience standpoint, they are different. You browse websites using your browser, whether it be Chrome or Safari or Internet Explorer. For APIs, what we are seeing is essentially what used to be done kind of in a very complicated way a few years back. Can also now be done on top of HTTP. So like the underlying technology is the same. In one case, it helps you, produce websites. And in that other cases, it helps you connect applications together, which is what kind of we call, APIs. So yeah, the underlying stuff, like the building blocks are the same, but the way you use it is pretty different. And I guess, we can dig into that in more detail as we go through the talk. But one of the most interesting things that we have seen is that because of these two, things being built on the same technology stack, it has kind of led to the adoption of APIs. It has made the adoption kind of much faster over the years.
Yeah, that makes sense. And you can even, there's a lot of different websites will actually give you give anyone access to sort of the more programmatic, or I guess the API of their site. So for example, you can go to duckduckgo.com, which is a search engine, and you'll get the box, and you can type in the box, whatever you want to search for, dog, and you'll get a bunch of links to dogs, and it'll look, they'll render that web page in a way where it kind of makes sense and it's pretty easy to navigate, right? But you can actually do, and I think it's as simple as just api.duckduckgo.com, and then not to get too technical, but then you put a little question mark, q equals dog. So if you type that URL, you're going to get something very different. You're going to get what's called JSON, which is JavaScript object notation, I think. But JSON is its own language, and you're going to get it looks like just a bunch of source code. But what that is that's data that's been structured in a certain way. It's not going to look pretty. It's not going to look anything like the DuckDuckGo landing page you're used to. And that's because it's ultimately not really meant for humans to read. It's a way for computers to, or let's say computer clients to go and make calls to DuckDuckGo, and then for programmers to get data in a way that they can easily interpret. And then they can choose to do whatever they want with that.
Yeah, absolutely. And that's I think one of the most interesting things about things like APIs. Once you kind of get that data in that format, you can kind of do lots of cool things with it. Like I remember kind of going back, when you had to kind of get data out of a website, you would probably write like a scraper, or you'd write a script to kind of take data from whatever was written into that document, in that HTML document, and you try to kind of build something to get that. Now it's much easier. You just kind of get the right API URL, and once you have that data in that structured format, you can build applications or just use it in very interesting ways.
Yeah, and a lot of public data, like for example, if you want to see all of the penalties from a hockey team, well, the NHL has their database, and they have a website. So you can go to, I don't know what the URL is offhand, but you could go to the NHL's website, and you can you can actually in your browser type in a certain query, and you will get back a bunch of data. And so, if you look at all of these apps, they give you up-to-date scores on sports events and things like that. Most of them are using this API, and the census has an API, and so there's just a treasure trove of information that you can get. So how did this end up sort of getting tied together with HTTP as a protocol? In other words, like, why did this evolve and not something completely different that would return the same data, right?
Yeah, no, that's a really good question. So, and I kind of found the answer a bit later, or at least I thought about the answer a bit later after kind of Postman took off. So, earlier, I think a couple of decades back, there was this whole notion of like web services, right? So you had things like SOAP protocols, and the whole idea was that, okay, when we want to transfer data kind of from one point to another, we would build this protocol, and this is the way things need to talk to each other. It was pretty verbose and pretty complex. And that it took off, I guess, within the enterprise, but didn't really take off so much within the wider kind of developer community. What I saw and what I myself used was like things like frameworks for PHP or Python. So whenever you'd be building an application and you had to kind of get some data from the user, you'd have a web form show up on your web page, and then the data would be transferred to your server using a post HTTP call. So I guess the APIs were there, but they were mostly in the background. Now, I think a few key things happened that helped APIs kind of grow on top of HTTP. So the first one I feel that was pretty significant was the introduction of kind of the iPhone and the rise of smartphones in general. So what developers kind of started thinking was that I have to build an application first for the browser and now for a device, and I want to make sure that I do kind of less work and let me standardize on whatever framework I'm using, but I'm going to make sure that this data gets sent off in a way that my smartphone can consume. So I think that was one bit, and then along with that, I felt what really helped solidify this was Ajax, where you would basically query the server to make some in-page update to your application, and you would do it over XML HTTP request. That's of course as people thought about the name. The name was kind of all wrong, but the core technology was built on top of HTTP, right? So what I think slowly started happening was people really wanted to build like interactive applications for the web and kind of more feature-rich applications for the smartphone. And kind of developers typically take the most pragmatic approach as if taken together as a whole, as a community. And they were like, we have these building blocks available. We have these frameworks available. JSON as a data format is pretty easy to use. That kind of became the dominant format. And I guess it took off from that.
Yeah, that totally makes sense. I remember, and I don't know exactly what year this is. I think it was around 2002. But I was one of the first people on Gmail. And I remember just being on Gmail, and then all of a sudden a new email arrived just while I was on the web page. And that just blew my mind, right? And I think similar people had that experience again when they saw Google Maps, a year or two later. And it's just, you could just scroll forever and it would just show you the next city, the next city. And it felt like everything was on your machine, even though it was being fetched in real time, right? It gave you this illusion like you really had the whole earth on your laptop, right?
Right.
And so, I think those are some incredibly powerful user experiences, and they only worked with web services because that's the only thing the browser really understood.
Yeah, absolutely. I remember using Gmail back then. I think I waited for a while to kind of get the invite, but once I got it, I was like, wow, this is one of the coolest things. Because, you used to kind of refresh the web page and it would be like, why doesn't this thing do it itself? And I think everybody saw that experience, and then, we're like, we need to have that too.
Yeah, totally. Hey, Patrick, did you get a Gmail invite from me or no?
It probably did come from you now that I think about it. That would
Yeah,
have
I
been
was
around the right
thinking that.
time.
So that I remember giving invites to people, and there's times where they actually had a website where people were offering things for Gmail invites. The one, I don't remember all of them, but one of them was they would give you, they're a tour guide in New York City, and they would give you a tour of New York for free if you give them a Gmail invite.
Wow.
Yeah, it was that transformative a technology that people were just lining up.
Isn't that crazy? Yeah. You had to wait so long. Like so many people were waiting, trying to get invites.
Yep. Yeah, I got mine
Yeah.
through Topcoder, and then I gave everyone I knew, I gave as many invites as I could. I think I had 75 invites to give out. Or no, I think it was 20, and then later on they gave me 75, and I never used the extra 75.
Wow, yeah. I remember when, whoever would get the Gmail invite, like that person would be, like they get like this cred in the local
Yeah.
community that this is the person who has Gmail invites, and they'll kind of, I guess that helped Gmail spread like crazy. I guess the storage space and the experience, like all of it kind of came together. I still use Gmail so there, right? Like
Yeah,
it was a great product. Yeah,
I'm sure there's some really fascinating marketing books written on how they really made the exclusivity just really drive up the value and make everyone just talk about Gmail.
I'm sure. Yeah, absolutely.
So getting more into testing and reliability and all of that. So let's say I build some web service, I spin up a AWS node, and I have some web service. I build an Express or one of these frameworks, right? How can I make sure that's reliable, right? The machine could die, people could pass crazy things to my web service. It's totally exposed on the internet, so I have to accept all sorts of requests that might be crazy. Like, how do you build a reliable web service with all that uncertainty?
So yeah, I guess that's a broad question. It kind of depends on the extent of how big the service is. I've seen kind of our own set of services go from very simple things to really large things. But I guess let me start with the typical developer workflow, right? So one of the first things that I kind of observed was the ability to kind of query the service and know its behavior as a developer. So, you're writing code and you're deploying code onto AWS, and you kind of want to check whether the API works as expected. So, you can query it with tools like Postman as your, service becomes more mature. You would probably want to write more automated kind of tests for it. You can check it, of course, every now and then, but you can't be sure that when you're not checking, it is working as expected. So you could, build some automation around it. And there are, a whole lot of ways in which you can kind of do that. Folks can write unit tests. There are integration tests, lots of different options available here. Once you know that, okay, most of this stuff is working, I've checked it manually and I've checked it in an automated way, and I've deployed to production and my service is working out there, you can monitor that service for correctness, and whether it's performing up to expectations. So you can have an external kind of monitor set up to ping your service and let you know whether things are working as expected. And I guess on the notion of reliability, there are lots of internal instrumentation that you could do within the service to, if you're emitting logs from the service, and that is something that you can process and check for on the server side, and make sure that everything's working as expected. The way I kind of see it is that it kind of goes through different stages, and those stages kind of depend on where you are in the development lifecycle. In the earlier stages, you'd probably be more ad hoc, kind of playing with the service yourself, and as you go more and more towards putting that service out in front of users and it starts getting used, you would tend to use more automated tools for that.
Got it. That makes sense. So it's kind of like so the service kind of works like it makes this request. So for example, going back to the DuckDuckGo example, it it every day at 2 a.m. it does some query, does some API call querying the word dog, and then on the back end, you're instrumenting that. Maybe there's some way to know, hey, this is a test query, and so when you pass that flag, it starts. You're keeping track of a lot more than it would otherwise, and it says, it makes sure, hey, did anything get returned back? Maybe if there's no results or it never actually returned anything because it crashed or something like that, then it would send an email to some developer and say, hey, the dog query, failed today, and that person would know, rather than having to wait until they get, reports from real people who are trying to use it.
Yep. That's how you should actually do it, because otherwise you have to get up in the middle of the night, and I've had those experiences. So yeah.
Yeah.
You should always tend towards automation.
Cool. Yeah, that makes sense. What about throughput? Like, what happens when someone, has just one machine that's servicing requests, and all of a sudden they start hitting, 1,000 QPS or 10,000 QPS or something like that? Kind of walk people through that sort of nightmare scenario and how they can sort of recover from that. I mean, it's in a way, it's a first world problem. It's like, imagine, you have some web service that's part of some product, and all of a sudden you get featured number one on Hacker News, and your web service just crashes down to the ground. Like, how do you sort of handle that?
So I mean, that's, I would say, if you get featured on Hacker News and your service is getting popular, it's kind of a good problem to have.
Yep.
And in some ways you can preempt that by load testing your service, or kind of just making or simulating that scenario yourself. So that's what we recommend to like a lot of people.
I see.
Without really waiting for that, I think you would want to do some levels of simulation before you deploy. In my experience, what we have seen is that as a service becomes kind of more and more mature, you kind of layer the service with different tools, and they help you kind of take in that load, distribute it across kind of different servers, and make sure that not like the load is kind of not on like one specific server. It kind of happens over time, but let's say you start with a very simple application, maybe taking the DuckDuckGo example that you had there, right? So in the initial phase, one person is sending the service, and it grows for a bit. A few hundred people are using the service. In most scenarios, you will be fine. Whatever you set up on AWS is going to be good enough to take that load. But as your usage starts kind of growing, you would probably want to make sure that it's not just one server that's taking that load. You might want to put a load balancer before it, and instead of deploying your service on one server, you deploy on multiple servers. And what a load balancer does for you is kind of distribute the load according to an algorithm, and it makes sure that your service kind of doesn't go down, right? So it takes in the service, redirects it to a particular, it takes in an API call that comes into your service and distributes it to a particular server. The server does its job and returns the response. If the server gets full, it would send it to another server, and it kind of goes on. So it really helps you kind of add more servers, and load balancers do like a very simple job of routing. So they can take in a lot of requests.
So the load balancer, is that something that you have to really? There's probably it's probably generic, right? So it's probably, you can just use something open source or something commercially available, and it would probably handle almost every use case. Or do you have to write something yourself?
No, most of these things are available. Lots of options actually are available for load balancers. I think AWS has something pre-built.
Oh, okay.
And if you don't want to use that, I don't remember exactly what technology we use, but you can get something pre-built from AWS, or you can pick up something from the open source world and use it. You don't have to write a load balancer yourself.
Got it. That makes sense. So you talked a little bit about simulating, events like simulating, what happens if I double my user base and things like that. Can you dive into a little more detail there? Like, how do you actually simulate? It just seems like such a chaotic system, right? Where you have people all over the world trying to access something, and then that volume of people kind of double. Like, how can you, kind of simulate? How can you prepare for something like that?
So I can kind of explain it from the perspective of Postman. We kind of looked at solving this problem, while building the product. So Postman lets you send like a request one at a time, right? So you built your service and you're sending sending requests one at a time. What Postman lets you do, and other tools also let you kind of do that, is automate this sending process. Right. So what you want to do is kind of write out a scenario. So in most cases, your users will be going through certain flows in your application, right, or in your web service. So they might be hitting like a few calls in a particular sequence. And the way most developers test stuff is that they're going to hit them one after the other, and they'll be like, that's done because it kind of works this way. But what happens when your service starts getting a lot of traffic and it has to scale up? Basically, this activity is happening, several hundred times in a minute, right? So what you would want to do is package this up. In the case of Postman, you can build a collection. That's Postman's abstraction for grouping together API requests, and you can run it in one go using a tool that we provide called Collection Runner. So you can just run it in sequence and essentially simulate the scenario of sending one request after the other. What the collection runner also lets you do is lets you run it across like several iterations. So very quickly it can send these requests one after the other, and you would get some basic sanity in your simulation scenario. Now, we also have tools that let you kind of export this collection out, and you can run it using an open source tool that we provide using the terminal. And you can run like multiple iterations of this, and you can run them in parallel. So we're not very sophisticated there. You have to kind of do some basic work there. But once this scenario kind of works for you and you have tested it across this debugging process, and then through like some lightweight automation process, you can use a more professional load testing tool that's going to run this scenario over and over again. And it can simulate, like a more professional load testing tool can send requests from different locations. So just think of these calls being made from places around the world. And once you kind of do that, then what you might start seeing in your server logs or kind of in your monitoring service is that the server starts behaving differently than what you started out with, right? So when you start out building something, you have the most pristine kind of assumptions of the service. But as your as this load testing system starts putting pressure on the server, your service might start behaving a little bit erratically, and you might notice issues of state. You might notice things kind of not working well between the server and between the application that is supposed to kind of receive the data. So lots of things can go wrong, and So it's basically a progression of things one after the other, and we would typically recommend doing this before you get featured on Hacker News.
Right, that makes sense.
That makes sense.
So basically, if I have a decent user base, but I'm going to have this big, I'm going to be at a NVIDIA GTC or something, which is a big convention, then I can combine Postman with one of these professional load balancing or I guess professional like distributed pinging type tools where they'll make a bunch of requests and all of a sudden it will feel like I have twice as many users, but half of them are fake. They're just you're kind of doing random things on your service, like making random queries. But at least it's making sure that you have the throughput so that when you go to that big conference, you turn that thing off, and hopefully that gets replaced with real people and it continues to behave well.
Absolutely, yeah. So on this side, you would have like load testing tools. On the other side, from the perspective of the service, you'd probably have load balancers and a fleet of servers ready to go. So you can, kind of like make changes without like bringing down the service. So yeah, this setup typically works for most cases. I'm guessing if you're Google or Facebook or a large company that has like millions of users, this setup will be much more sophisticated in its kind of complexity. But if you're a developer or you're a startup starting out, this would take you through a long way.
That makes sense. So like like when you have an actual website, there's this concept or there's this technology called cookies, which basically means you sign some information on the browser, then some encrypted data goes to the server, and basically the server has the I'm trying to figure out a way to explain this really quickly, but let's just say the server has access to some data. The server can pass that to the browser, and the browser doesn't actually really know what it is. But the browser can pass it back to the server, and then the server can decrypt it and say, okay, this is sort of some state information, right? And so through the cookies, the server can, so for example, if you were to, and I don't know if this is actually, Patrick, you can correct me on this, but I mean, if someone was to actually take the cookies off of your computer, they could probably log in as you, on a website, because that cookie is sort of, when it gets to the server, it's telling the server that the server is going to unpack that cookie and then realize, okay, this person has already logged in, 5 minutes ago. And so they're authenticated, right? And so is there, when you're building web services, is there a concept of state and how does that work? Like, I mean, do you still do cookies in a web service or is it done through some kind of token or something like that?
Mm-hmm. Yeah, so cookies are still used in authentication mechanisms in web services. In my view, they don't give the best experience to the developer because your web service is going to be consumed outside the browser. So what essentially kind of happens in this interaction is that the server basically expects that, okay, there is some piece of identifying information when a call comes in to me, right? And when a service is being called through a browser, a lot of this can be hidden behind the scene, like the cookie mechanism takes care of it. And wherever, if you're using an existing language framework, a lot of them take care of this for you. So if you have built a web service and you're using a language framework like Slim for PHP or I guess Ruby on Rails or something, then it will automatically kind of do it for you. But this can, like, consuming the service becomes harder when you are doing it outside of the browser. So if you're kind of writing your own API client and you want to make a call to that server, typically servers support a token mechanism, or they would support one of these authorization authentication protocols like Auth1, Basic Auth, or Auth2. There are lots of these available, and what they help you do is kind of provide a scheme through which you can say that, okay, I'm a valid user of this particular API call. And there are some optimizations you can make with these systems. So let's say if you're using Auth2, you would have to be registered with the service, and then you're going to get one kind of a token, and then you're going to exchange this token with another token, and then finally you are in an environment where you can make calls. But it's your responsibility to kind of keep the token unlike the cookie mechanism where the browser does it for you. In this case, you would have to keep the token and manage the state of the token. And in some cases, the server might say that the token is not valid anymore. More complex authentication schemes manage that. But in some cases, like basic auth, you can essentially generate a token and send it for a successful API call until the password changes. So when you move from building web services for browsers to kind of web services that have to be consumed in a wide variety of settings, you might want to adopt some of these more protocols that are more suited for this kind of authentication.
Okay, that makes sense. Yeah. So basically, you would have one endpoint in your web service that's login, and it would take the username and password, and it would return back some token, some really large number. And then once the person has done that, then the next time they try to call something else, like, give me all the search results for dog or something like that, they would pass in that large number that you gave them in the first call. And that person would, the receiver would then assume that person's good for a certain amount of time or something like that. And I'm sure it's more sophisticated than that, but at a high level.
Yeah, API security or like web service security is like a big topic, and as with scaling up services, it kind of gets more and more sophisticated, because as it depends on, again, right, like on the context in which the web service is being used. But what I would recommend, like every developer to do from the get-go is keep this consideration in mind. Because if you think of this when you've gone to production, maybe if you're featured on Hacker News, somebody might be trying to get into your service, and they might not have the best of intentions.
Yeah, that makes sense. Also, it's really important to, this is just in general, to use libraries and to look at sort of the standard way of doing things. I built a website a really long time ago. And I did this authentication type thing with the one I just described, which is like very primitive. But I put the token as a query parameter, like I put it in the URL. And so what happened is people went to my website and they said, oh, this is really cool. And they copied the URL and sent it to their friend. And they didn't know, but they were actually sending their friend the token. So when their friend went to the website, their friend all of a sudden was logged in as that person. And so that's an example of just, I had no idea what I was doing. And I made something that was just completely insecure. And so, you definitely want to, use a lot of these like OAuth 2 and things like that. I mean, they've gone through, and I remember when I integrated OAuth 2, I thought, oh, this is really strange that they're sort of having me jump through all these hoops. But then in hindsight, it was, oh yeah, that's because when you don't do this, other people just get everyone else's password. so when it comes to security, and this is true for everything, even if you need to encrypt, a chunk of data in memory or something like that, use libsodium, use libcrypto or gcrypt. Don't write your own AES or Blowfish or your own encryption algorithm. And just anything with respect to security, it's so important to use, off-the-shelf products. And Postman probably integrates with almost all of them.
Yeah, that's right. Actually, Postman can help you do the opposite. Like it can help you break into stuff, or you can help you test for whether you are, making a common mistake. Mm-hmm. So kind of going off that example that you mentioned, that, if you put something inside the query parameter, it's going to be copied. It's more visible there, and people will copy and send it to people, and of course that's a breach of kind of security. One of the more interesting things, and this is something that we have seen in production scenarios, where people will put something inside an HTTP header, and they'll think that, okay, this is not seen by the user, right? They only see the URL, so maybe I'm safe like that. And they will put some sensitive token inside the HTTP header. And your HTTP header can be inspected by Chrome's network inspector, or we have an extension called the Postman interceptor which can capture calls and send it off to Postman. And it kind of captures the entire HTTP packet, which is basically your web service call. And you can see the entire set of things that are being sent from the server. And if your API security is not proper, then you can actually extract kind of things from the header. Lots of interesting ways I think I've seen people use stuff, but you can use Postman for just a basic sanity check on whether your server is returning something sensitive which you don't intend to. And it can reveal some surprises.
Yeah, that
Sometimes,
makes sense. I mean, you could have a list of Postman, fake accounts on your website, and if the Postman service logs in as somebody else, you know that something's gone horribly wrong.
Yeah, absolutely.
What about if you do mobile development or even web development, there's this concept called gremlins. And so actually, if you're out there and you're a mobile or web developer and you haven't used Gremlins, you should check it out. It's really, really fun. I've used it a lot on web. I know it exists on mobile, but I haven't tried it there. But for web, there's, I think, gremlins.js. And what it will do is it will literally do random things on your website. So in other words, it will click on random places in your website. It will just type keys. It'll click and type keys and then click somewhere else and just it has no rhyme or reason. And what you'll find is that it will break your website. Because you have sort of a assumption in mind of how your website's going to flow. And then this thing just doesn't care. It will just type anywhere. It will type in the search bar, and then while you have, the prefix search coming up, it will try to log in. And your website will just fail in spectacular ways. The other thing it can do for web, which is particularly sinister, and a lot of people don't even bother protecting against this, but on the web, there's really nothing stopping someone from clicking buttons that are hidden, right? Just because you have a button hidden is really just a little notation in the HTML. The button is still there. The code is still there, and people can click buttons that aren't visible. And so this Gremlins thing has an option where you can turn on, which gets really aggressive, and it will try to, unhide things and click them. And most websites break with that. Is there something similar in Postman where it just does basically a Monte Carlo and just tries all sorts of crazy API calls and sees if it can crash the endpoint?
So it's not kind of pre-baked in, but you can build that in Postman. So Postman has a runtime built in that is basically built on top of JavaScript. And what you can do actually is attach JavaScript calls, scripts, JS scripts before and after your API calls. So think of it as a sequence of stuff. First one script runs, then you make your API call, and then another script runs, and this script, which we call a test script, can essentially analyze the response that is returned from that web service. So it's so what a Postman collection, which is the thing that stores all this stuff, can do is just help you script any scenario. So you can do things like go one after the other, or you could change the flow of how the collection will be run and go in random directions, or you can inject different kinds of data into the web service. So one of the most common ways to kind of break a web service is to inject very large strings into the API call, right? And you wouldn't want to kind of type that stuff manually. You can just write that in the script that runs before the web service call, and you can generate kind of fake data. Or there are interesting attacks that you can do for the service, which would probably want to make the server emit some sensitive data, for example. So you can do all of that with Postman using the scripting runtime that's there, and it's built on JavaScript, so it's kind of pretty simple and easy to use. So you can do lots of interesting things there. You could run it as a chaos monkey kind of a thing too.
Yeah. Oh, yeah. That's another word for that. Is chaos. How do you prevent something like that? I mean, if let's say so on the browser, you can log in with a username and password, right? And the browser, maybe if you type in a really long username, there's a check on the browser, some JavaScript that runs on the browser. It says, hey, username can't be this long. But someone can easily just bypass that, and they can make a call directly to your web service with a username that's, 13 megabytes long or something like that.
Yeah.
Yeah. What is the defense against that?
So, I guess the first rule that you have to follow is don't rely on client-side testing. So don't expect that, that JavaScript test that you have on the client side or in your app is going to prevent it.
Mm-hmm.
You have to write checks on the server side. So in your server code, typically this features in terms of, sanitizers that run before you actually process any data that comes in from a user. So one rule that you could follow is just don't trust user data. The moment you kind of put a form out there and there is a field in which somebody can put in something, just expect that there is going to be something malicious, and then you check for how you are processing that data. The moment it kind of hits your server and it goes to your application framework, you would want to make sure that you sanitize it. I'm sure there are tons of libraries available to help you do that. So just like the way you don't have to roll your own crypto library, you can use something that's available in the open source world and use it to sanitize your data. And finally, when you work with user input, you kind of make sure that you have checked for some of these things. So a lot of this can be automated. Some of this is just basic kind of awareness that you might want to have, making sure that any interface that you expose to the outside world will probably be hit with malicious data. And once you work with that assumption and you chart out how this data is kind of flowing through your service kind of processing systems, you can take actions against it. In some cases, just adopt a library, or in other cases, just kind of make sure you have some basic checks in place.
Gotcha. That makes sense. Is there my guess is there's probably, I don't know much about the HTTP protocol, but it probably has some maximum, I guess like packet size or request size built in. So someone couldn't put in like a 400 megabyte username or something like that. At some point, I guess the protocol itself would stop that, right?
I think the protocol prevents that sort of stuff against like query parameters or URL characters. Where things can get a little hairy is when you have a request bodies. Request bodies could be arbitrarily large, and I think that could trigger buffer overflow attacks and things like that. So if you have like in most servers, the server will process the request and might just ignore the body altogether. So you don't have to worry about that. And it would have those checks, which are protocol driven for what is coming in as an input on query parameters or headers, though you can do something malicious with that too, I'm sure. But when it comes to bodies, I think I don't think the protocol specifies a higher limit. We have seen feature requests where people are like, I have like, this crazy file that I need to upload. And on the client side, we run out of memory to process that request. But I guess the protocol allows for arbitrary large stuff.
Oh, I see. And so early on in the server, while you're reading this TCP stream at a really low level, you say, okay, either the header says that this body is going to be, a gigabyte, so I just forget about it. Or, I've read 10 megabytes and there's no way a username is even close to that, so I just drop the rest of the packet and close that request or something.
Yeah, I guess these checks would be built in Apache or Nginx, which I'm guessing would be the more common options you'd be using at the server level.
Makes sense.
I guess the server request size is not something we've seen a problem, because people are not rolling off their own servers. The tricky part is always in user input validation. Like that's the one that trips up a lot of people, a non-sanitized input, or something like an XSS attack where people put in like JavaScript and you kind of store the JavaScript in your database and you render it as it is back into your web page, and that can essentially reveal your cookies. So the
Wait,
more
can you dive in detail on that? That went
Huh?
over my head. So the idea is you
Oh,
make a username that is JavaScript, and then when the server, yeah, can you run that by me again?
yeah, sure. So basically, let's say you have you have no sanitization on what a user will enter in. Let's say you have like a sign up form and you're asking for somebody's name,
Okay.
right? And somebody enters in a bunch of JavaScript in there, and what you have on the next page is that this name is going to be displayed after somebody submits the form, right? So somebody puts in some JavaScript code in there. This goes to your web service, and you're like, yeah, I love my users, I trust my users, I'm going to put this into the database. And when you go to the next page, you pick up the same value, and uh, in some ways, this thing can be crafted in a way that in this piece of data will execute in the browser, right? And what happens is, I think this is called an XSS attack, where
Yeah, cross-site scripting attack.
yeah, right. So when this JavaScript executes, depending on the way it's crafted, it can reveal some sensitive information to the attacker.
Oh, I see. So basically, like, so you have, a spot in your HTML for the person's name, and then you're just going to take the name out of the database and just drop it in that spot in the web page. Maybe it's in the top right or something like that. And what someone's done is they've made their name, start JavaScript, look at all the cookies, convert them to plain text, send them to my server in Russia, and JavaScript. That's the person's username. And then when that name gets, displayed on the top right, boom, that executes. Cool.
Yep.
Yeah, that sounds pretty dangerous. I think a lot of that, Postman could probably help with a lot of that, because my guess is you could do some checks to make sure that data is if the person says maybe you could go into more detail on how that works. Like, do people give you a spec and then you find if there's a way for you to violate that spec? Like, how do people use Postman to verify that their validation is correct?
So the way it works in Postman is you would write a validation script for this. So Postman is a pretty kind of flexible tool. We don't it's not specifically built for this use case, but we kind of give you the interface to kind of send API calls, and then you have this runtime that kind of executes these validations. Once you kind of receive the response. So, and then you can automate the process. Right?
Oh, I see. So you have like a Postman automatic request where every day at 2 a.m. someone tries to make a username called, get all cookies. And and every day that request fails. And the one day it doesn't fail, we get an email saying, hey, somebody, made the site insecure.
Yes. So in a nutshell, it would kind of work like that. You would have to go through a bunch of steps. Like, you would build a collection, you would write your web service call, and then you would test for this specific thing. You would run it manually, and then you would automate it as part of your test suite. And then you can set up a Postman monitor, which will run this test against your service. So in the future, let's say you make somebody makes a mistake, somebody comments something out, and this test kind of fails, then you're going to get an email saying that, hey, something's kind of wrong with your service, and a validation that you set in place is not working anymore. The way we've kind of built the product is that it doesn't have to come to a point where you deploy something kind of wrong in production, right? You can catch it either manually, or if you're doing your automation test suite, you're running it regularly. So typically you would catch it early on, and in the worst case scenario, of course, you can set up a monitor, and the monitor would have to alert you.
Oh, that makes sense. So you have like a canary version of your web service, and Postman's the only person using that. And if you find some error, then it won't, roll your canary into the production version.
Exactly right. So the way we have seen systems or web service deployments to kind of go is people have a development environment that runs on your system, So you are writing code in your IDE, and you have all of this configured on your local system. So you basically are developing on localhost, and then you have a staging environment where your team is kind of working together and deploying kind of all your web services and putting them together in one place. And that kind of acts as a check before you go to production. And then finally, you have the production environment, which is what your users are seeing. So in Postman, actually, we have a pretty cool feature called environments that helps you take out parts of your request and convert them to variables. And you define those variables in these environments. So you could have a development environment, a staging environment, and a production environment. And each of these environments will have like different values for the variables you set. So you can set, like if you set the staging environment in Postman, all the calls that you are sending in Postman will now go to the staging environment, right? Or if you're running a monitor and you set the environment as production, all the calls will go to the production environment. So Postman kind of makes it very easy for you to kind of work across different environments. And this is the typical setup that we have seen, kind of like a 3-stage thing. In some cases, it's more extensive. I think I've seen like environments where there are like 7 different kinds of like stages. But yeah, we kind of saw that and we built that into a feature called literally environments in Postman.
Yeah, that makes sense. So what about like in terms of the product? What's sort of the like what's the pricing? Like how does Postman actually work from a sort of product perspective or business development perspective? Like you charge per endpoint, or how does that work?
So Postman is free for everybody to download and use for making calls. So there is no restriction on the number of calls that you can send, because it kind of runs as an application on your machine, and you make the calls on your network, right? So you can just download Postman and use it as much as you want.
Oh, cool. Is it open source, or is it like how does that work?
So all the core components of Postman are open source. The application itself, like the desktop application, is not open source, but the runtime and the collection format, a bunch of SDKs are all open source.
Got it.
So kind of going above from that, you can sign up for an account with Postman, and that's also free. And using that, you get access to more advanced features in Postman, like building mock servers. So you can build a mock server and simulate the behavior of a request very simply, which is basically like sending an API call and returning like a fixed response. So you get that once you sign up. You can generate a documentation web page through Postman, which will run in your browser. It's not tied to the app anymore. You can set up these monitors, and we'll make kind of calls for you to make sure everything's working with your web service. And all of this stuff is also free up till a particular point. So you can make, for example, 1,000 calls through Postman monitors in a month, and then after a month, this will renew. So this is typically good for small projects or proof of concept things. And if you want to access more of this stuff, then you can become a pro user of Postman, and that is at $8 per user per month, and you get a lot more of these advanced tools. And for our enterprise product, which is more tuned towards larger companies, the price is higher. For developers, yeah, you would be on pro.
Cool. So if someone wants to, if someone's in their dorm room and they've built something which returns basketball scores or something like that, they can use Postman totally free. I mean, they're probably not going to hit the 1,000 query limit. Definitely not, right away. And yeah, they would be set for a while with just the free package. And then if all of a sudden their site becomes more popular than NBA.com, then they have all the infrastructure in place and they can scale up.
Yeah, I mean, I'm guessing if you are at that level, then probably you're paying for other things a lot more than you'd be paying for Postman.
Yeah, totally.
But yeah, you can use it for as long as you want for lots of interesting stuff. You can build lots of interesting things in Postman for free. We have now more than 5 million users across the globe now. Postman is used in a lot of university courses as part of boot camps and programming classes and stuff, and we are actively supporting that. So it's kind of very exciting for us to see the product kind of being used in essentially helping developers learn about APIs and web services.
Cool. Yeah, that's super, super cool. So tell us a little bit about the company. So what's it like, working at Postman? Where are you located? What's your, office like? Are you hiring? These kind of things. There's a lot of people listening out there who are either looking for a job or they're in university, which means they're almost certainly going to be looking for a job in the next few years, and give them kind of a taste of what it's like, to work at Postman and what opportunities there are.
Sure thing. Yeah. So we started as a startup in 2014, and we've been growing pretty rapidly kind of since then. We have an office in San Francisco and we have an office in Bangalore, and we are hiring for lots of different roles. We have kind of our marketing and customer success teams here in San Francisco. We have our developer evangelists here as well. Our engineering team is in Bangalore, as well as our design team. Mm-hmm. And I think now we are more than 50 people.
So what is that? Can you just tell people really quick, what's a developer evangelist? A lot of people might not know what that is.
Sure, yeah. So developer evangelists for us, now traditionally developer evangelists basically try to kind of weave in, or they try to kind of explain a company's technology to other developers. They build interesting use cases for let's say the technology that the company has built on its own, but they also talk about open source tools and technologies and how things kind of fit together. And their job essentially is to make developers make the best use of components that are available in the developer ecosystem. So it's a lot of education, it's a lot of teaching. A lot of coding as well, where you would probably be building, plugins or integrations with different technologies to kind of illustrate kind of new and cool use cases. You might be presenting at conferences or meetups. That's what our developer evangelists do. They kind of, organize our meetup and tell people about, interesting things that they could do with Postman. So it's a very, I'd say it's a relatively kind of new role for the wider kind of startup ecosystem. Companies like, I guess, the bigger companies like Microsoft and Google have more professional programs, but now you can actually work as a developer evangelist in a lot of startups and mid-sized companies.
Cool, that makes sense. And so you mentioned you're in the city, so are you you're in maybe like a high-rise in Soma or something like that?
Yeah, so we recently moved to a new office.
Cool.
And it's on Market Street on 2nd and Market.
Okay.
Yeah, we
cool.
got we literally started in the basement in SF. We started in a co-working place, then we moved one level up to the 2nd floor, and now we are on the 11th floor.
Nice.
So yeah, as Postman has been growing, we're kind of moving up.
Yeah, literally moving on up.
Yeah.
Very cool. Well, yeah, this has been really fascinating. I mean, as I said, I made a fool out of myself building a website a while back, and I still I've learned a lot over the years. But one of the biggest things I learned is to rely heavily on services, and that allows the developer to really focus on the bigger picture, which is tied to whatever they're trying to build and however they're trying to improve. Whatever kind of product space or human condition or whatever they're focused on. And so, yeah, this is another great tool. And the really nice thing about this service, this product you built is that, it sounds very accessible. Anyone can really get started using it. A lot of people are now using web services for almost anything. A lot of these things like, remember Patrick, what was it called? The thing that was kind of, I want to say it was like Corba or something like that.
That is a thing, yes.
But there were these like before web services really took over, there was, SOAP was one of them. And there was these other ones where, I guess you could.
Yeah, RPCs.
Yeah, I mean, I guess you could call like, gRPC and, Thrift and these kind of things, put them in that category, although they're still around. but now pretty much everything has moved on to web services. And so there's probably a bunch of people out there who have built web services to as an accessory to an app that they're working on or a website that they're working on, and they could plug right into Postman, for free, and make sure that what they're building is kind of solid, which is really cool.
Yeah, absolutely. Yeah, thank you. Glad you like the use case. We started, actually we have a stronger kind of hypothesis. What we kind of started seeing from talking to our users, that a lot of ways in which they're primarily developing kind of actually driven through web services. You have lots of interesting APIs available now, which you can just kind of drop in and call, and you don't have to think about every little detail. You can, for example, use Stripe, and you can get very powerful payments platform working for you. You can you can call AWS S3 API, and then you kind of get a very powerful storage API. And I really like the S3 API because it's kind of really small and kind of does so much for you. So what we kind of started seeing was that the way you will build software. Of course, you have all of these other ways in which you will kind of be writing code and compiling code and kind of building the more traditional application. But that application is always either going to be using APIs or might be just composed of APIs. So we're pretty excited about this whole thing, because first of all, it's very accessible. You have to use these are all built off HTTP, so it's pretty easy for you to use in any language, any framework, any which way that you want to use it. And it's super easy to kind of get started. You don't have to download thousands of dependencies or understand a very complicated language, maybe like Corba or something like that. And that's really kind of helping this whole ecosystem grow very quickly. Any conference that you kind of go to, every company kind of has an API out there. And it's kind of becoming more of a prerequisite that you have APIs so that developers can build something more interesting. And they just don't have people who are users of your product don't just have to depend on just what you provide out of the box. So it's a great time to kind of be a developer, and build cool stuff using
definitely.
web services.
One thing that I really didn't understand early on as a developer was how to really combine languages, right? So for example, you might find this really great library on GitHub, some open source library for, let's say you're making a poker app, and you find a really great library for telling you the hand. So in other words, you just give it the 7 cards. If you're playing 5-card stud or something, right? You give it your set of cards, and it will tell you, oh, you have a pair, or you have a full house, or you have a flush, or something like that. And so someone wrote some really great code to do that on GitHub, but it's in, I don't know, Go, the Go language. Mm-hmm. And you've written, your whole poker backend service in Java, right? Well, so, you can do things like swig and things like that, but it gets ugly really quick. Like trying to call one language from another. I've done it before. It's not pretty. You really don't want to do that. And so what you want to do is wrap that, poker hand evaluator in some type of web service, or some type of service, and then have, your Java code call into that, even though it's on the same machine. Have your Java code call, access, localhost port 70 or something, and pass in some poker hands and get back some scores. That might be easier than either having Java go through JNI to talk to Go, which is kind of a nightmare, or rewriting this entire open source library in another language, right?
Right, absolutely agree. So that's a recurring challenge kind of in reusing software functionality, right, everywhere. So in some cases, things work out. You might find the library that you want in your language, but when you build things off, in a web service, you can consume it kind of anywhere. There is that additional overhead of kind of running the service, but it's typically small in the long run. The more interesting kind of aspect that I'm very excited about is when you kind of build a web service and you have it operate, pretty reliably and robustly, then you can actually really build larger and larger pieces of your software pretty easily. You know that this piece is going to stay this way, and you have abstracted out all of its internal concerns. Maybe next time you want to write that thing in Java, but the things that depend on that web service only talk HTTP, right? So you can really change the internals of your web service and write it in a new way if you want to make it more performant in any other language. But as the interface is set in HTTP, you don't have to, cause a disruption in pieces of software that consume that service. So it really is like, I feel like it's a nicer, cleaner abstraction for building, larger pieces of functionality. And we are seeing that with, kind of organizations adopting things like microservices, or really using, small APIs kind of glued together, rather than just going completely off, big pieces of software, monolithic packages, if you may.
Yeah, totally makes sense. Cool. Yeah. Thanks again for coming on the show. Fascinating. I think. Oh, let me give you a chance to tell everyone, how can they, get to the website, and also what social networks you're kind of most active on, so that if they want to, get started, where should they go for that?
Sure thing. Yeah. So we are at getpostman.com. So it's super easy to think about. Get and post actually are the first two HTTP verbs which you will use in building your web service. So yeah, think of that. And it's getpostman.com. And that's where actually the name Postman also kind of comes from. Helps you post stuff. And we are on Twitter. That's where we are most active. My Twitter ID is A85, so 3 characters. And we are at Postman Client for our official Twitter ID.
Cool. Your Twitter handle is A85?
Yeah.
Wow. A 3-letter Twitter handle. That's pretty cool. Were you really
I've been registering for these services very early on.
Oh, yeah. That's super impressive. Yeah, very cool. All right. Well, thank you again. And people know how to reach you. It's only 3 letters on Twitter, folks. So if you have any questions for Abhinav, just go for it. Cool. Thanks a lot.
Well, thank you so much, Jason. Thank you so much, Patrick.
The intro music is Axo by Binar Pilot. Programming Throwdown is distributed under a Creative Commons Attribution Share-alike 2.0 license. You're free to share, copy, distribute, transmit the work, to remix, adapt the work, but you must provide attribution to Patrick and I, and share alike in kind.